Let's talk a little bit about variation. Specifically, let's focus on direct and inverse variation. When two things vary directly, they can be modeled by the equation y equals k times x, where k is just a constant and x and y are the two things that you're comparing. To have a direct relationship, as one thing increases, the other thing increases as well. Or maybe something decreases, then the other thing would decrease as well. So think about this. Maybe you're driving a car and you set the timer and you just start driving. As that timer goes up, the distance that you drive also goes up. So we could have x be your time. So as x goes up, y would also go up. And k in this situation might be how fast you're driving. And that would determine how many miles you go in a certain amount of time. But as your time increases, your distance increases, which would make that a direct relationship. An inverse relationship is one where as one of the things increases, the other thing decreases. So that's going to look more like this. Now x is in the denominator, so as that denominator goes up, your quotient is going to go down. Now think of this. You've got a bunch of cookies and you've got a few friends that you're going to share the cookies with. As that number of friends goes up, the amount of cookies that everybody's going to get is going to go down. So this would be an example of an inverse relationship. So let's go ahead and look at a couple equations and see if we can determine if the relationship between the variables is direct, inverse, or maybe it's neither. So we've got 6 to talk about here. We want to decide in each of these 6, do x and y vary directly? Do they vary inversely? Or are they neither? Remember, in a direct relationship, we're going to be able to write it as y equals some constant times x. And in an inverse relationship, you're going to see y equals k over x, where k is still some constant. But there's no adding, no subtracting, no exponents. These are very basic relationships. In number 1, I have y equals 4x, which gives us a direct relationship between x and y, because I have the form y equals some constant times x. So k in this example is 4. In number 2, we have y equals x squared. Now this is a problem because there's an exponent, and there's no way to manipulate that exponent to make this fit either direct or inverse. So this is going to be neither. Number 3, I notice that x is in the denominator with a constant on top. There's a -2 in the numerator, and y is equal to the quotient of those two things. So this fits an inverse relationship. Number 4, you might see the fraction and think automatically it's got to be inverse, but notice that x is on top now. So it's not going to be inverse because in an inverse relationship, your x is in the denominator. Here, I can actually go ahead and separate out that 4 as 1/4 times x. And this then matches the form of a direct variation equation where y equals kx. So this one is actually a direct relationship. Number 5. I see adding, which automatically fails both direct and inverse. So this one is neither, just like number 2. And number 6, I see a negative exponent, but we know what to do with negative exponents. That negative exponent is just going to cause our x to drop beneath the 5, making this an inverse relationship. So that's a little on how you would recognize it from equations, but what about if we're looking at a table? Remember that for direct, the relationship between x and y is that y equals some constant times x. And for inverse, the relationship is y equals k over x. In both of these, I can solve for k and see how do x and y work together to get that constant. In a direct variation equation, I can divide both sides by x. So y over x would give me k. And remember, k is a constant. If x and y vary directly, k is the same value for the whole example. So when I divide y and x, I should get the same value for k for all values of x and y. And for inverse, I can solve for k by multiplying by x, and I would end up with x times y equals that constant. So when I multiply all of my x and y values, I should get a constant number, meaning the same number for all x and y values that I multiply. So let's go ahead and take a look at these two tables and see how this works out. In my first table, I'm told that it's direct, so let's look at those x and y values. Remember that when I divide my x and y values, I should get the same value out for every pair. So let me check this out. I'm going to take my y value and divide it by the corresponding x value. So my first fraction would be 20 over negative 5. And because this is a direct relationship, we're told it's direct, I should get the same value out when I divide the next two corresponding x and y values. So 12 and negative 3, 0 and 0, and negative 16 and 4. 20 over negative 5 divides to negative 4. 12 divided by negative 3 divides to negative 4. 0 over 0 is a little bit of a special case. Remember that we have no adding allowed, no subtracting allowed, which automatically means that every direct relationship is going to have an ordered pair of 0, 0. It's always going to pass through the origin. So this fraction here is actually the only exception to our rule. In every other situation, when we divide, we must get negative 4, with the exception of 0 over 0. My last one, negative 16 divided by 4, is negative 4. So all of these had a quotient of negative 4, showing that my relationship is direct. Now for inverse, I'm going to take the product of corresponding x and y values. So I'll start with these two. I've got negative 6 times 2, and I get negative 12. Here I've got, again, negative 2 and 6, which gives me negative 12. 3 times negative 4 for that third ordered pair gives me negative 12. And 4 times negative 3 gives me negative 12. So the product of all four of these pairs of x and y values is negative 12, showing that it is an inverse relationship. So let's try a couple. We'll take a look at a couple tables and we'll decide whether they are direct, inverse, or neither. So remember that for direct, we are going to take the quotient of our y and our x, and we should get a constant value. And for inverse, we're going to multiply x and y, and we should get a constant value. Taking a look at number 1, I'll start by checking the quotients. I'll take my first pair of y and x, 25 over negative 10, and I get negative 5 over 2 when I reduce the fraction. My second ordered pair has 10 and negative 4. 10 over negative 4 gives me negative. When I reduce 10 and 4, I get 5 over 2. So far, so good. My third ordered pair is negative 5 and 2, so negative 5 over 2 is negative 5 over 2. I can't reduce that any farther, but that's okay because it already matches. My last pair is going to be negative 15 and 6, and when I reduce these two, I can reduce them both by 3. I get negative 5 over 2. So all four of those pairs had a quotient of negative 5 over 2, meaning that the relationship in number 1 is direct. Let's look at number 2. I'll start by checking direct again. So number 2, my y value is negative 3 and my x value is negative 7. The only way I can simplify here is by reducing those negatives to 3/7. My second pair has a y value of 1 and an x value of negative 3, which doesn't reduce any farther at all, and these automatically are already different, so we fail. This cannot be a direct variation relationship because I already have two different values. So let's go ahead and check inverse. If this is an inverse relationship, I take the product of the corresponding x and y values, and I should get a constant. So first, -7 times -3, which is 21. Second, I multiply -3 and 1, which gives me -3. Again, we've already failed, so this is automatically not an inverse relationship. So I can go ahead and say that this relationship is neither direct nor inverse. Number 3. Again, I'll start by checking direct. So I take my first pair of x and y values and I divide y over x, which reduces just to positive 4/3. My second pair would be -6 over -2, which reduces to positive 3/1. Again, we automatically fail because we already got something different. So we'll go ahead and check inverse. Multiplying my x and y value, -4 times -3 is positive 12. My second pair, -6 times -2 is positive 12. So far, we're looking pretty good. My third pair is 4 times 3, which is 12. And last, I have 6 times 2, which is also 12. So sure enough, when I multiplied all the corresponding x and y values, I got the same product for all four pairs, meaning that this is an inverse relationship. Our last one, number 4. I'll go ahead and check direct. My first pair is 0, 0, which would give me the fraction 0 over 0. And if this is direct, remember that that is the only exception to our rule that they must divide to a constant value. So I'll go ahead and move on to the next pair, 2, 1, which would give me the fraction 1 over 2, which I cannot reduce. Third, I have the point 4, 2, so y over x would be 2 over 4, which reduces to 1/2. So far, that matches my other 1/2. So I check my last fraction, 4 over 8, which does reduce down to 1/2 as well. So 3 of my ratios reduced to 1/2, and the fourth is our exception for direct variation, making this also a direct variation relationship. And that's it. Thanks for watching, and I'll see you next time. Bye.